The triangle law is a corollary of the parallelogram law. It is used to find the resultant of two vectors at a time. To find the resultant of two concurrent forces drawn as directed arrows, a triangle may be constructed using these two forces as the sides. The second force to be added should be drawn starting from the head of the first force. The third side, drawn from the starting point of the first force to the arrowhead of the second force, represents the magnitude and direction of the resultant of these two forces. Let us now demonstrate how to use the triangular law to find the resultant of concurrent forces. Remember, in the description of the triangular law or triangle law, this can only be applied if you are going to solve for the resultant of two concurrent forces. Concurrent meaning the forces are meeting at a common point, just like in our example shown here. So, to find the resultant of our forces, let's copy this first force, that is force A with magnitude of 10 dynes. And then we will copy the second force starting from the arrowhead of the first force. So this will be your B, force B. This is 15 dynes. You can have your resultant taken from the starting point of the first force going to the arrowhead of your second force. This is your resultant R. Or you can start with your force B. This is your force B, 15 dynes. And then head to tail addition, this is your 10 dynes. The resultant would be the same. This is your resultant R. So either way, if you will start with this force or the other one, you will arrive with the same value of your resultant. So luckily this is in 90 degrees. We can easily solve for the resultant using the Pythagorean theorem. So by using Pythagorean theorem, it should be Pythagorean. R is equal to the square root of 10 dynes squared plus 15 dynes squared. So R is equal to 5 square root of 13 dynes. To determine the direction, we can use this angle. Let's name it theta. This would be tangent of theta is equal to the opposite side, that is 15, over the adjacent side, that is 10. Your angle theta is equal to the arctangent of 15 over 10. In that case, that would be equal to 56.3099 3247 degrees. Thus, our resultant with its magnitude and direction is equal to 5 square root of 13 dynes (56.3099 3247 degrees measured from the horizontal. Or you can replace this expression from horizontal by north of east. So that is how you apply the triangle law. Now, what is a force polygon or head-to-tail addition? Although the triangle law is similar to the parallelogram law, its application to force systems involving more than two vectors makes it more convenient. This extension of the triangle law is what we call force polygons. Let's recall that the triangle law is similar to the force polygon. That is basically the foundation of the idea of force polygon, or what you also called as your head-to-tail addition. It uses the same concept with the triangle law. It is just that the application of force polygon is more convenient since it can be used for force systems involving more than two forces. So for this one, let's try to start with 20 pounds. Head-to-tail addition. This is 20. Let's add 10 pounds. And then your 5 pounds going to the left. So if you will look at this horizontal forces, 20 minus 5, 20 minus 5, the length of this force will be equal to 15. And then we can find the resultant using this head-to-tail method. This is your resultant R. This is in 90 degrees. We just move this force so that we can simplify our analysis. So this is your angle theta. So if you will isolate this triangle, you can use Pythagorean theorem to solve for the value of R. The value of R is equal to the square root of 10 squared plus 15 squared. R is equal to 5 square root of 13 pounds. And its direction can be taken from tangent of theta, since that is measured from the horizontal already. Tangent of theta is equal to the opposite side, that is 10 pounds divided by 15 pounds. So theta is equal to the arctangent of 10 divided by 15. This is equal to 33.6900673 degrees. Now your resultant is equal to 5 square root of 13 pounds, 33.69006753 degrees from the horizontal, or can be written as north of east. That is your resultant using force polygons. Thanks for watching. If you like this video, don't forget to hit the like and subscribe button and turn on the notification bell.